The next one is going to deal with areas of a polygon and an apothem and a kite and a rhombus. Okay. Most important thing is area of a kite or a rhombus. Okay? Area of a kite or a rhombus. Okay, think about this. Diagonal 1 times diagonal 2, I think it's divided by 2, I better make sure. Diagonal 1 times diagonal 2, yep, divided by 2 is the area of any rhombus or kite. Have that in your note. Diagonal 1 times diagonal 2 divided by 2 equals the area of a rhombus or a kite. Okay? Area of a rhombus or a kite is diagonal 1 times diagonal 2 times the two diagonals times by 2. You got it. Or divided by 2. And you got it. Okay. So that's going to be pretty easy. Now we got to use the apothem or the apothem. And by the way, it can be pronounced either way. I looked it up just to make sure because I didn't know how to pronounce it. So apothem or apothem is how you can say this. I'll probably say apothem, but we're going to do that in here. I'm going to show you why. Let's take a regular pentagon. What does regular mean? All the angles are the same and all the sides are what? The same. Let's call this 8, just for funsies. Okay? What's this angle in this? Oh wait, let's not do that. Let's do a hexagon first because it'll be easier to show. Sorry, let's do a hexagon. My bad. Let's do a hexagon. Okay, there we go. Horrible hexagon. It's not even close to regular. But let's pretend it is. What are each of these angles?
60.
360 divided by what? 6. Do it.
60.
That's a 60-degree angle. Everybody agree with that? Okay. Mark the center point of that hexagon. Middle of the hexagon. You with me so far? Okay. I'm going to say this is 8 still. That side length is 8. Okay. Drop that down. Make a little triangle there. Actually make this the whole triangle. Okay? I know this whole length from here to here is 8. Okay? What's from here to here?
4.
I agree. This is a right angle. Do you agree? If this angle was 60 and I drew this right through here, what does that have to be? 30. What's this?
60.
If this is 4,
5.
what's this?
4.
Yes, 4 divided by the square root of what? 3. I don't know what that is. Somebody do it on your calculator. 4 divided by the square root of 3.
2.3.
This is 2.3. And then what is this length right here? 2.3 what? Double. Agreed? What's 2.3 double?
4.6.
2.3 double? 4.6. Everybody agree? Okay. Now, what's the area of, watch this, what's the area of that triangle?
Wait, I got it.
4 times.
What's the area of that triangle?
Wait, what?
Big one and the little one.
The big triangle. Yeah, you do. What's the area of a triangle? Make sure this is in your notes if you don't know it. Base times what? Height divided by 2. What's the base? 8. Times what? 2.3 is the height. Not the 4.6, this is the height.
Are we allowed to use notes?
Divided by what?
Two.
On the test tomorrow?
Yeah.
Absolutely not.
I think yes.
2 goes into 8 how many times?
9.2.
4. 4 times 2.3 is?
9.2.
9.2. How many of those triangles are there?
6.
Times that by 6. What'd you get?
55.2.
So 55 point what? 2. Say, huh. Okay. I'm going to say something that's a little bit trickier here in a minute. Okay? I just figured out a formula. Did you? The area of a regular polygon. What's the formula for that?
Area of the triangle times number of sides.
Okay, but what is, well, how will I find the area of the triangle then? What's this? Is it?
Radius.
No, the radius is actually that. If I was to draw a circle around this,
Okay, you're right.
true,
You're
'cause
right.
it's
the radius would be the 4.6. Everybody see that?
Yeah.
So what is that?
The apothem.
That's what the apothem is. The apothem or the apothem is actually this perpendicular value to a side, perpendicular bisector to a side. So you might want to write that in your notes. An apothem is the perpendicular bisector of a side of a regular polygon. That's the apothem. Okay? So the apothem is the perpendicular bisector of a side of a regular polygon. Okay? Now, what's the area of the polygon then? It's actually kind of interesting. It's half of the what? The apothem times what? What's this base? Side length. Isn't it? Yeah, because that was the side length times the apothem times what? The number of sides.
Is that say
Okay.
area?
Yep. Area of a polygon is 1/2 the apothem times the side length
Wait, hold on.
times the number of sides. Okay, let's try one a little
So the
tougher.
A stands for apothem.
Yes, A stands for apothem. Okay,
Wait, what about the side? What is the side?
side length.
Okay.
Yeah, the side length. Okay. Oh, there's another way to think about this. Okay. That was 8. How many 8s is that? 6 times 8 will be what? What is 6 times 8 representing? What is 6 times 8 representing?
Length of side times number of sides.
I know, but what is that?
It's the number.
No. What is it? Like looking at it.
Perimeter.
Yes, very good. Nice job, Caleb. Yeah, this is the perimeter. Okay? The perimeter. So there's another way I can write this. It's a lot simpler. What is it? The area of a polygon is equal to 1/2 the apothem times the what?
Perimeter.
Perimeter. That's the easiest way to do it. Because the side times the number of sides is, side length times number of sides, really is the what?
So how do we find
Perimeter.
apothem? Like 30, 60, 90? Is that
Ah, very good. That's what we're going to do next. Okay, watch. Here's a weird one. This one, not nice. It'll work, it's just not very nice. Okay, so this will work, it's just not really nice. Okay, so Jacqueline, what's that angle measure?
2, 3, 4, 5?
Yeah, you do.
I can't.
360 divided by 5.
72?
Is it 72?
I just was supposed to say 3.
I'll go with 72.
5 divided by 360.
360, because all these would have to add up to 360, is that true? Do all those have to add up to 360?
Yeah.
How did I get 60 over here? 360 divided by 6, right? So yeah, I agree. This is 360 divided by 7, that's 72. Everybody agree with that?
Yeah.
Okay. What's half of 72?
36.
That angle right there is what? Everybody agree with that?
But
Okay.
that's not 30, 60, 90. So now how do we find the...
And then, calm yourself. Relax. Okay, we know that's 36. I'm going to tell you that this pentagon has side lengths of 10. Okay, so every side length is what? 10. In fact, you already know the perimeter. What is it? 50 is the perimeter. You agree with that?
So the 72.
50. Everybody agree that 50 is the perimeter. But I need half of that and then times the what?
Divided 72.
Apothem. The problem is I haven't found the apothem yet. Can I find it?
Yeah,
Yeah. What's from here to here?
5.
I agree.
We have... Oh, that's dead. Never mind. Okay, I'm ready.
Are you going to be okay?
Yeah. I was just trying to...
Do you need a hug? Okay, let's check it. All right. Sam, how will I find this? The apothem.
I have no idea.
You need to start paying attention then. Okay, to find the apothem, A, from this angle 36, you're going to use SOHCAHTOA.
Yeah.
SOHCAHTOA. Do I want to use sine, cosine, or tangent?
Tangent.
Opposite over adjacent. I want to use tangent. Tangent of 36 equals opposite over adjacent.
What the heck?
Yes.
Isn't that what we've already done that, haven't we?
Yeah.
Yeah, we just barely did it like last chapter. Times both sides by what? 5. That's my apothem. That was the question that MJ was asking. How in the heck am I going to find the apothem? The answer is you're going to take half of the angle, right, because it's regular. You're going to find that angle by dividing by how many sides from 360. You're going to take half of that, that's how I got 36. Then I'm going to use SOHCAHTOA using half length of the side to find out what that apothem is. This is it. 5, 10 of 36. To the nearest tenth rounded, what did you get?
3.6.
3.6 to the nearest tenth rounded, yes?
Yeah.
Am I ready to go? Yeah, replace this with what?
3.6.
3.6. Half of 50 is 25, so the easiest thing to punch into my calculator is what? 25 times 3.6. What'd you get? What?
90.
90?
Mm-hmm.
About 90, huh? So about 90 is the area of the what?
Triangle.
Pentagon. The whole pentagon area is 90. I can do that with any regular what? Polygon. Now I'm going to give you a tricky one. I'm not going to draw it. Okay, I'm not going to draw it. See if you can figure it out. Decagon. This is the key formula. Got it? Decagon. Side length. Regular, sorry. Regular decagon, side length of, let's make it hard. Let's go 11 centimeters. Okay? What's the area? So the perimeter is, that's the first thing, that's the easiest thing to find. Because it's 11 times what? The number of sides. 10. 11 times 10 is 110 centimeters squared. Well, perimeter, centimeters, just centimeters right now. Okay? What's the hard part that I got to figure out?
How do you say it?
The apothem. What? Do I want to draw all 10 sides?
No.
No, I really don't care what all 10 sides are. What I'm going to draw is this. The key is that.
So there's 10 sides?
36 cut in half, 18. Everybody agree with that? Don't forget to cut it in what? Half. That's where the mistakes usually made. Okay, because you'll do 360 divided by what? 10. Everybody will do that. And you'll get what? 36. And you'll think that's the angle. But it's really what? Half of that. So that angle is 18. How far is it from here to here?
11
Five.
divided by 2.
5 point what?
5.
5.5. Because the whole length is MJ what? What's the whole length?
11.
11. So that's how come that's 5.5. How am I going to find A? Memory? Nope. SOHCAHTOA. So am I going to use sine, cosine, or tangent?
Well, you have the opposite, so then it
And I have the adjacent.
yes.
Opposite over adjacent is tangent. So I'm going to go tan of what?
Will you always?
18. No, I'll show you one where you don't. Good point. We'll do the next one so that you can see that. Tangent of 18 equals what? A over 5.5 times both sides by what? 5.5. Do that on your calculator. 5.5 times tan of 18. Somebody.
1.8.
1.8 is the apothem. Now can I do it? Yes. 1.8 times 55. Where did I get 55?
Half of 1.8.
Half the perimeter. That's your answer.
99.
The area is 99 centimeters squared. Pretty cool, huh? Okay. Question from Cordner. He says, well, won't we always use the tangent? And what did I say?
We'll see in a minute.
I said, no. I'll show you in a minute. The minute is now. Now is the minute. Okay, you have a circle.
That was a good circle.
That's one of my best. Okay, so here's my circle. Still sucks, but that's okay. There's the radius. Okay? The radius is 10. I'm going to draw a octagon, regular octagon, in my circle. So I'm going to inscribe it. Okay, the octagon is inscribed in this circle. How many of these sides will there be? 8. I don't care, really. Okay, here we go. A little better here. Dropping that bad boy down. That's a what? Right angle. What's the area of the shaded region? If this was the shaded region and I had an octagon. Now, I mean, it goes all the way around. You with me? I just don't want to draw the whole thing. But this little shaded region, what's the area of the shaded region if I had an octagon inscribed in a circle? Well, what's the area of the circle? What's the area of the circle? We just learned that today. It's cake. The area of the circle is cake. It's pi r what? Well, r is what? It's 100 what then? 100 pi. That's the area of the circle. Everybody agree with that? Now, what's the area of the octagon? That's what we just learned. So first of all, I don't even know the length of the sides, do I yet? But can I find it? I sure can, because I can do 360 divided by 8, which is
45.
And then cut it in half.
22 and a half.
22.5 is that angle measure. Everybody agree with that? This is weird because I want to find the apothem,
So now we
but I
use
want to
cos
also find
tan.
that x value because I don't even know the perimeter yet.
So we use cos
But I can find it. I've got to use a whole bunch of stuff, not just what?
tan.
Tangent. I've got to use cosine and I've got to use sine. Let's do the apothem first this time. And if I'm finding the apothem, I got to do what? Sine or cosine?
Wait, which one's? Can you explain me?
Sine.
Sine. Yeah, SOHCAHTOA.
I know, I just forgot which one is sine.
Well, from this side, from this angle, this side is what? Well, yeah. This side is what? Nope. There's the right angle. It's the what? Hypotenuse. That's what I'm going to use. Opposite over hypotenuse, that is what? Sine. So the sine of 22.5 equals A over 10. 10 sine of 22.5 equals A. What did you get? Sam? What'd you get? I know, you need to pay attention. 10 sine of 22.5. Punch it into your calculator, quick. What'd you get? Make sure your calculator's in degrees, by the way. 3 point what? 3.83. Okay, good enough. Okay? Now, I need to know x, because I need to know those side lengths, right? How do I find x, MJ? What will I do? Sine, cosine, or tangent? What do I want to know? Adjacent.
A, so can you do tangent?
I could use tangent, but this is a rounded value. I always want to avoid using what? Rounded values, right? Use the values given and avoid the rounded values. It's adjacent over hypotenuse. What's adjacent over hypotenuse? Cosine. So I'm going to do cosine of what? 22.5 equals x over 10. Okay, times by 10. Do that on your calculator. What's x?
9.2.
9.2. Now, is that the length of a side? No. What's the length of one side of this octagon?
Double. 18.4.
Double that. 18 point what? 4. If it's an octagon, this is the side. If it's an octagon, what's the perimeter?
9.8.
Perimeter. Somebody tell me what it is. What'd you do to 18.4?
Times
Times by 8. Do it.
147.2.
What do I do with perimeter and apothem?
9.
Times them and divide by what?
2.
2. Do that on your calculator. 3.83 times 1.47.2 and divide by 2. Yes.
So how come that angle is 22.5 degrees? Why isn't it the top angle?
This one?
Yeah, why isn't that 22.5 degrees?
Did I do this wrong?
It's
I don't
fine.
think so,
It's fine, just pretend it's right.
because that's 16 divided by 360. You're dividing it into 16 triangles.
Oh my gosh, I'm doing it wrong.
Yeah,
teaching us
that's
wrong
the last
the whole
You just told us
triangle.
It's fine, it's fine.
It's fine. We're just going to change this to our angle.
Okay,
Because, yeah, you're right. So, by the way, then these are wrong, right?
Yeah.
But that's okay, we can fix it. It won't be hard. This is still x and this is still a. It's just that this time, what is it then?
Wait.
It should have been the sine of what?
Not.
22.5 equals, yeah, the values are just switched, right? So this was what? 3.83, and what was this one?
But so you would get the same answer.
You do get, but they're just switched. This is side length and this one's
But
the
you
other
would
side
get the
length.
same answer.
You'll get the same answer. The apothem, though, is what?
Different.
What was the apothem then? It was the old side length. What was it?
Can't remember.
18 point, or no, was it half of that?
It was
9
nine.
point something.
0.2.
9.2, okay? So now I'm going to take 18, or 3.83 and double it. Do that. 3.83 times 2. 3.83 times 2, what'd you get?
7.66.
7.6 what? 66. And then that's the whole one, and then times it by 8 so that we get the perimeter.
61.28.
61 point what? 28.
Yeah.
And then I gotta times that by the apothem. 9.2 and divide by 2. Sorry, that's the area of the.
Wait, so why is 22.5 the top angle now?
Well, so when I cut this into 8 parts, So think about, I'll do a 6 again.
It's literally the same answer that we have.
It is going to be the same answer, but that's just because those two are the same. This angle up in here is really the central angle that you're dividing by 360. How many of these are there? 6. So that's why when you do 360 divided by 6, it's really that angle. I was saying it was this one, but it isn't. It's this one up here.
Okay.
And then, so it's just half of that. That's how come that's 30. Yes?
I'm just thinking also did the same thing with the decagon example.
Right. Would have been the same on a decagon. But it's okay because you're going to kind of get the same thing anyway. You're going to end up with the same thing anyway. So my area is what?
281.88.
Okay? And I got to subtract that from what?
100.
100 pi.
Which is 300,
What'd you get? 300 and what?
14,
314 something. Point what?
2, 5.
No, 32.
Do 100 times pi.
Oh, I just subtracted.
100 times pi. 314 point what? 15. And subtract 281.88 from it.
Subtract what?
281.88. 32 point what?
I think I did something.
No, that sounds right.
I got 32.27.
32.37. And this is going to be centimeters squared or whatever. Okay, now, here's the next question. What's the probability of a point being in that shaded area?
Subtract from what?
Don't subtract.
Divide,
Add.
Divide, that's the area of all these shadeds.
divide that by the half.
Divide that by the area of the circle, right? So take 32.37, what's the area of the circle?
348.50.
Divide that by 314.15, and what's the probability that a point is in those shaded areas?
10%.
What is it?
10.3%.
10.3%. Okay, so that's how you'll do the next assignment, which is, you can stop that, 10.